another applications of rational equations are is work rate problems. Okay, so this kind of problem is basically like, if you are working alone by yourself and then cleaning the room, you can finish in a certain hour. And if your sister is cleaning the rooms, she will finish it in a certain hour. Now the question is, if you working together, if you and your sister working together, how fast can you clean the room? So that kind of scenario that we are talking about. And then it's really is useful, and then in a real life cases, because especially on an assembly line, how fast you can work and how fast the other person can work. If you combine it, like, in a short amount of times, like, how many what is the maximum amount of like product can be done, so that the company can, like, save the cost of like hiring people in the long hours and stuff. So, but we will be looking at a very fundamental idea right here, right? The formula is the job done is equal to how fast you can work times with the amount of times that it takes you to finish the job. Okay, so the job done is the rate times the time, right? How fast you can work and times with time. And the partial job done, complete by per hour, is basically 1 divided by amount of the times that you need. So your textbook sort of explain it into partial job done idea, and then I will go slightly different so that you can sort of like understand. Okay, and the way that I'm gonna mm, uh, interpret it in this case is because this the job done, we are always trying to complete one job. All right, so our job done will be always one. That's our goal. Because, for example, if you are assigned to clean one room, if you finish cleaning up the whole entire room, that will consider as one job done. Your assignment is done. Or if you are assigned to clean 10 rooms, if you finish five, that's it's not your job is not done yet. So therefore, your assignment or the job that you need to finish up is always one job. That's how I will be interpreting. Okay. So by interpreting that way, one job is equal to rate times the time. So like before, if I want to know the times, then I can divide one divided by the rate, it will give me the times. Or or I can also look at one divided by time will equal to what? The partial job done, which is the rate that you going. So to organize this type of prompts, always I'm going to be using the chart because we can use the formula. So it will be rate times the time is equal to job done. Okay, rate time the time is equal to job done. So in here, we're going to have scenario like this. Individual case is going to go right here. Okay, this must be individual. Let me rewrite this. And I want to fill in individual case right here. And then the last portion, we're going to put it together. Okay, together idea. Because the together part will help me to set it up the equation. So let's take a minute to read these questions. One gardener can mow the golf course in 4 hours, while the other gardener can mow the same golf course in 6 hours. How long would it take if two of them together working together to mow the golf course? So we have gardener one, and then we have gardener two. And this is what I'm talking about. We want to look at only the individual case in this job. So both of them is doing the same job, which is to finish mowing the golf course. So the job will be one, right? And the first gardener take 4 hours, so the time is full. And the second gardener take the 6 hour to finish by itself, so six. So from here, I know that the rate that we got will be 1 divided by 4, which is using this, right? The time 1 divided by the job, right? The job that you need to finish divided by the time. In this case, is one job, and it takes 4 hours, so we divide it. And similarly, the gardener too, it will be one job divided by what? 6. Now, what we are interested in is working together. And what we are interested in is how long does it take for them to work together. So we don't know the time that needs to finish, right? The times that they need to finish. So working together, we are still cleaning up one job, right? One trying to mow the same golf course, which is one job. But this time you are working together, so therefore your rate will be the combined rate of those two. So that means your rate will be 1/4 plus 1/6, the combined rate from two gardener. And then the time is the one that we don't know, which will be x. This will allow us to set it up the equations, which is the rate 1/4 plus 1/6 times with the time x that is equal to finishing one job. So this last row will help me, okay, will help me to get my equations. So now solving this is there's a few ways that you can solve. It's up to you how you want to solve it, right? So first I can combine these two 1/4 and 1/6. I can combine them together. So that will become 5/12. If you use a calculator or if you do on a side work, you will get 5/12x is equal to 1. And if I multiply both sides by reciprocal, that will become 12/5. Right? So now I know that the time that they need together, right, working together will be 12/5, which is in another way of saying is 12 divided by 5. That gives me 2.4 hours. So I can say that needs 2.4 hours to work together. That will be the final answer. So make sure remember this. You need individual case on the first two row and then together case always on the last row. And only the together case, in the together case, your rate can be combined. Okay, only this portion can be combined because you're working together. The rate can be combined. And sometimes the rate is not always adding together. It could be subtract also. And then, for example, like, if you are cleaning the house and then all the your kids start messing it up right after you clean up. So that means that, they're slowing you down. Okay. So let's take a look at on the next example. So Alex can paint the room in 6 hours, and Christina help her. It takes uh, it takes them 4 hours to paint the room. And how long would it take Christina to paint the room by herself? So my first step, the formula. This is a work rate problem, so I will write down my formula. Rate times time is equal to job done. Okay, you have to write down the formula. And then we know that we're going to have individual case. One is Alex, and the other one is what? Christina. And the last one will be together case. And we are trying to finish the job as one job, which is painting the room. And the information that we know from the Alex is Alex will paint the room by self will be 6 hour. So therefore, the rate will become 1/6, right? The job time divided by the time. And Christina will be painting the room also, but never give you what is the time that it took her to paint by herself. So therefore, the time in this case will be x. So therefore, it will be 1 over x. And together, working together, they will be painting the same room. And this time, it said that working together, right? If Christina helped us, it will take them what, 4 hours. So therefore, the times for working together is 4 hours. And we know that the rates, since they are working together, it must be the combined rate, which is 1/6 plus 1 over x. And remember, this last row will help me to get my formula equation setup, which is the rate of working together, 1/6 plus 1 over x, times with the times working together, that will be equal to 1. So for this problem, first we're going to distribute it. 4 times 1/6, that will give me 2/3. Plus 4 times 1 over x will be 4 over x is equal to 1. Now we need to multiply both sides by LCD to clear the fraction, which is 3x. Multiply 3x to the left-hand side, multiply 3x to the right-hand side. So this gives me 2 over 3 plus 4x is equal to 1. Distributing it, 3x into the first fraction. 3 and 3 cancels it out, so it will be 2 times x is 2x. Plus, distributing into the second fraction, x and x cancels it out, so 3 times 4 is 12, equal to 3x. Subtracting 2x to both sides, now I got x is equal to 12. And that tells me how long Christina will take to clean by herself. So therefore, my final answer, Christina will take 12 hours to paint by herself, right? To paint by herself. And